Hi guys, welcome to my channel. Today we are doing a very interesting topic in mathematics, grade 12 functions. You see, in grade 12 you may assume that you know everything to do with functions because you started with functions as from grade 10 and 11. But I must tell you now, there is so much that is missing in functions because we have been just given the graphs, how to sketch the graph, how to find the equation of the graph once the graph has been plotted. But you don't really know what a function is. That information has been kept up until you do grade 12. And today we're going to go a little bit backwards to define what a function is. But before we can do that, we can never understand a function, what a function is, not up until we discuss the relations. We'll start with seeing or defining what a relation is, and then come to the formal definition of a function. This is the stuff, this is a very exciting stuff. Just hang on there. Just make sure that you have your pen and paper to take notes. Let me ask you a little question. When was the first time you heard about functions? Grade 10? Not really. The function didn't start in grade 10. They started way back. I think some of you have done, not however that you are doing functions since from primary school. Because most of you, you know, or you have heard about number machines. Number machines is nothing different. It's exactly what we do in functions. But there you were introduced in a very basic way. But now we're gonna give you all the definitions, everything that you have to know to tackle functions in the final examinations. Just wait a moment. To illustrate this fact further, as you can see there on the screen, we have got number machines. Some of you are already laughing that I'm taking you to grade 8 or to primary school, but I just want to show you the similarity of what we are doing and what you've learned elementary in primary school. Here, this stuff that you're seeing on the screen here is what you've been doing in primary. You can see there on the screen that let me have my laser there. You're having an input there, something that is going into the machine, and then the machine does its own process there, and what comes out there is called an output. So this is the things that you've done in primary is not anything new. That is the thing that I wanted to show you, learners, that the number machine and the functions, the relations that we'll be discussing is not anything new. It's the stuff that we've done a while ago. So let's go back to where we're supposed to do. So there we have got functions and relations. And you can see they have written functions. That means when you are doing functions, you must expect some fun. And you are most familiar with relationships, I believe, more than relations, but relationships and relations are more the same thing. So we'll be discussing not relationships today, but we will be discussing relations in mathematics. So let's get started. What are relations? Be careful of these definitions here. It is defined as follows. A relation is any association between two variables, usually x and y. In life, there are many relations, but we stream down in mathematics and look only for those that we can quantify as x and y. But it is not a matter of math, learners, that you must always use x and y. You can use any letters, but for formality and not to be confused, mathematicians decided to use strictly or closely to x and y. So we have got many types of relations. Let's explore those relations a little bit more. If we look there, different types of relations, we have got a many to many. But what type of relation is a many to many? Many x values are mapped to many y values. So in this kind of relation, there are no strict rules. So everybody can mix with anybody. So there are no strict rules. Many x values can be mapped to many y values. That's the first one. The second one is a one to many. That means it's a one, if we look at the definition there, one x value is to many y values. If we can take this maybe to relationships, the part that you know the most, I believe that you are familiar with. We can say maybe one boy is associated or is having many girlfriends, which I believe that is not supposed to be the case, but that is what that relation means, that one X value is mapped to many Y values. The third one is a many to one. When we're having now many boyfriends, many boys are associated with one girlfriend. Those are the things that happens, isn't it? I can see that you are agreeing with me. So this one, we have got many X values associated with one Y value in mathematics. And the last one is a one-to-one. It's an odd ideal situation. This one is an ideal situation. Why? One X value is mapped to one Y value. So we call that kind of a relationship a one-to-one relation. I believe that even in your relationships, that's what you are looking for, maybe to have a one-to-one relationship, not a many-to-one or one-to-many. I cannot even say about the many-to-many relations. Okay, so that is it about the relations, learners. Where is this all going, learners? These relations. Because first of all, we have to have an association. Once you have two things and there is an association between them, then we define what we call a relation. But now, from the relation, we can define what we call a function, because a function is a special relation. So in just a moment, I will define with you what a function is. What will be the difference now between these relations and a function? Just hang on there a little bit more. If we go back to our main slide, we have already discussed there what a relation is. Remember, learners, we said a relation is any association between two variables. So we usually use X and Y. So let's define now, let's see what a function is. A function is a special relation whereby each input point, called the domain, is associated to a unique output point called the codomain or the range. So now we can see, learners, again that there is that association, but this association is a special one, because it's not just a random association. You must make sure, learners, that you read the statement carefully and that you understand every little thing there, what it means, because the power of understanding what a function is relies on your understanding of the statement. Let's read the statement over. A function is a special relation whereby each input point, called the codomain, is associated or is mapped to a unique output point called the codomain or a range. Let's just look at some few examples to ensure that we all understand what a function is. So you will decide whether what I'm giving to you is a function or not. So to test whether we understand what a function is, let's look at these couple of examples here. Let's just make sure that you read the definition of a function carefully, and make sure that you understand every little thing that is being said in there. So in our example here, we have got two sets, A and B. So that means when we want to have a function, there must be two things, and there must be a relation. You can see there, those arrows are showing us the relation that is there between these two sets. So now obviously we can say here we're having a relation, and now we want to test whether this relation is a function or not. So using the definition, can you tell learners if this is an example of a relation? Let me give you a minute to decide. I can see some of you are undecided. Some of you are already jumping to say it is a relation, and some it is a function, and some of you are saying no, it is not a function. Everyone's supposed to have a reason by testing this against the definition of a function. But I can tell learners with whatever conviction that you have that this is an example of an example of a relation, but not a function. This is not a function. Why am I saying that? In the definition, it says everything in A must be assigned. And you can see there we're having a 4 that has not been assigned to anything in B. So by that reason, this fails to be a function because it says everything in A must be assigned to something in B. This one is failing because of this 4 that has got nothing, no relation with anything in B. If again now we're looking at number 2, you have got those two sets again, A and B. Now we have to decide whether this is only a relation or a special relation called a function. Again, I will give you a minute to decide by looking at this. What would you judge? Would you say this is an example of a function or not? Let me give you a minute to decide on that. Okay, so you have your decision, but let's discuss what is happening in here. If you look at this now, looking at A, we have got 3 elements in A. All of them have been assigned to something in B. So that condition passes. So because the emphasis is never on B, but on A. Everything in A must be assigned. So this one passes to be a function, irregardless that D has got no relation with elements in A, because the emphasis on the definition of a function is on A. Everything in A must be assigned. Let's look at another example. So if we're looking at this one now, where you need not to take these things for granted, you must be careful when you are analyzing it. Test it against the definition of the function. Make sure that you understand the definition, what it says. Okay, again, we're having these two sets and we're having a relation. These arrows are showing that there is a relation between A and B, but we want to test whether this relation is a function again. So I will give you a moment again to decide as to whether these two are the typical example of what we can say a function. Yes, learners, I think you have already made your choice because it's only 2 choices to say it's a function or not a function. But I can guarantee you, I can assure you that this one is not a function. It's not an example of a function. Where is it failing on the definition? First of all, we can see there in A, everything has been assigned. Can you see that? We agree on that. That condition is satisfied. But now it continues, the definition continues to say that everything that has been assigned must be assigned uniquely. If you're looking at 2, is not assigned uniquely. 2 is assigned to A at the same time is assigned to C. So number 2 in A fails the uniqueness. So this one now becomes a relation, but not a function. Remember, everything in set A must be assigned uniquely to a point or to an element in B. There must be a uniqueness assignment from A to B. So that's why this one is failing to be an example of a function. Lastly, but not least, let's look at this one, our example 4, as to whether it would be an example of a function. Let me give you a moment again to decide whether you say it's a function or not. What are you saying? Okay, this one, if we look at set A and set B, there is a relation. Now, to test whether it is a function, we have to look at all the conditions in the definition. First of all, everything here in A has been assigned. You can see no element in A that hasn't been assigned. Now, let's check now the uniqueness. Is everything in A assigned uniquely to elements in B? You can see there what is tempting. 1 is assigned to B and 3 is assigned to B. But these 2 elements are assigned uniquely. No element in A is assigned to 2 things in B. You can see 2 is assigned to A and 4 assigned to C. So this is an example of a function. It qualifies to be a function. Now, learners, with that, those examples having been done, I think you had fun in there, and also you were disappointed at some point that your decision whether the example was a function or not didn't come to your expectation, but that is part of learning. So let's look at some other important things when we're looking at the definition, because there we spoke of a domain and we spoke of a range or codomain. What the range and what the domain is basically. Let's look at that in a moment. Again, if we are revisiting our definition of a function, we said a function is a special relation whereby each input point called the domain is associated to a unique output point called the range. So now we want to know what exactly a domain is. So now the domain of a function is the set of all permissible or possible values, usually x, for which the function is defined. So in our examples, learners, our A was our domain. So it's all the values where the function is defined. We're looking at only the values where the function is defined. Hence, the first example didn't make it for a function because not everything in the domain was defined for the function. So the domain is are all the values of x for which the function is defined. Again, we have heard of the output value in the definition. If you look there, we said then to the is associated to a unique output point called the codomain or the range. So now we would like to know what exactly is the range. And now let's look at the range, learners. What is the range of the function or the codomain? Now, by the definition, the range of a function is a set of all the output values, usually y, belonging to the function. So that means when you're looking at the domain, we're looking at the x values horizontally. And when we are looking at the range, we're looking at the y values, the vertical one. So the range are all y values which belongs to the function. So those are the two things. So in our examples, A was the domain and B was the range or codomain. We call it a codomain if not everything in B is assigned to something in A. So we call it a codomain. But if you only taking the elements that are mapped from A, then we call that the range of the function. So that is the difference between the domain and the range. Now we move on to what we call function or functional notation. There is a lot of confusion between the two, but now we will clear out that confusion. So, for instance, if now we're having f of x is a function notation that describes the output value of the function for each input value. For most of the time, people or learners confuse f of x as being a function. But let me tell you now that f of x is not necessarily a function, but it describes the output value for the function. If we carry on with that understanding, then we can see that same applies with, because we're not only using f, we can also use g of x, h of x, p of x. All of these are the description of the elements of the range for each function. So if you're using g of x, that means it's a function depending on x. It's the value of y or the value of the range depending on the input, which is x. So that's what f of x is. It's not necessarily a function, but we use that to say f of x is a function. But the real meaning of f of x, it describes the element of the range for each element of the input or of the domain. So that's what it is. Secondly, learners, what do we mean by f1 equals to 2? So you can say there the function value of f at x equals to 1 is 2, or the other way we can say f at 1 is 2. That's what we mean by this. So in here, that means you substitute into the formula 1 wherever there is an x. If maybe it was f of x plus 1, that means in the place of x you replace it with 1, and then you'll be having 1 plus 1, which is equals to 2. So let's clear up that little bit of confusion that is mostly done by learners most of the time. So We have got different function representations. We can describe or represent the function in 5 different ways. So the first one is a set-built notation. So in the set-built notation, you're having there, if you see it like that, it's still the function, but now it is in a set-built notation. How do we read this? We say the set of all xy such that y is equals to 3x plus 2. And the second one, we have got a function notation, the one that most of you are familiar with. F of x equals to 2x squared. The value of f at x is equals to 2x squared. So that's how you can read this. Next, the next one, we have the set of ordered pairs. So this one is very unfamiliar, but it's another way that we can represent a function with. You can see there, 1 is mapped to 2, 2 is mapped to 2, 3 is mapped to 4, 4 is mapped to 6. So it is also a function because you can judge easily there. There's no repetition of the y values, whereby 1x is mapped to 2 different things. So this is a function. This is a typical example of a function. The last one, no, not the last, the second last is the graphical way. So I think also this one you are very familiar with because you have been doing the graph since grade 9, doing the graph of a straight line. In grade 10, we introduced a whole lot of other functions. So this is another way of representing functions. The other one that I didn't include in this slide is the verbal way of representing a function. You can also represent, you can also say your function verbally. You're not restricted to use only these 4. So now we have got different categories of functions. Remember, now we've defined what a function is, and then we can look at these different categories of function. So a function is a relation which is either one-to-one or many-to-one. Remember how many relations do we have, learners? We had 4. We have got many-to-many, we have got one-to-many, many-to-one, and we have got one-to-one relations. But now when it comes to function, we take only 2. So a function, it can be either one-to-one or many-to-one. Other than that, it's not a function. So let's look at it. When do we say a function is one-to-one, and when do we say a function is many-to-one? So first of all, a function is one-to-one if each input value is associated with one output value. So that is a one-to-one function. I believe that in your imagination now you can already pick up or say which function are one-to-one to the ones that you know and which one are not one-to-one. The second category, a function is many-to-one if there are many input values associated with one output value. Again, in here, I think you already know what function might be many-to-one function. Now that we have discussed all of this, now I think you have a clear picture of what a function is and what a relation is. When can you say a function is one-to-one, and when can you say a function is many-to-one. So now we're gonna look at another information that is very critical for understanding function, which is highly examinable in grade 12 papers. If now you are given a graph, how do you tell whether that graph is a graph of a function? Now you're not given a formula, you're not given anything, but you're given a graph. How do you tell that that is a graph of a function? That is what we're going to look at in a moment. Now we have got what we call a vertical line test. So this test, basically what it does, it tells you if given a graph, it tells you whether the graph is a graph of a function. But what does the vertical line test says? This is what it says. A graph is a graph of a function if whenever we draw a vertical line and move it from left to right, the line intersects the graph only once. Do you understand this, learners? Let's go over it once more. A graph is a graph of a function if whenever we draw a vertical line and move it from left to right, the line intersects the graph only once. Let's look at these examples to make sure that we fully understand what is being said in the statement. So let's say we're having this graph. Now the question is, is this the graph of a function? Okay, here is a line there. Can you see the line? Let me point at the line there. Here is the line for us there, learners. Can you see the line? We draw that vertical line and then we will move it to the left. So what are we expecting to see? If this is the graph of a function, we're expecting this line to intersect or to touch the graph only once. If it touches it more than once, then that would mean that is not the graph of a function. Let's see what is going to happen, learners. So if we look at that line there we go. That line intersects the graph at two places. Obviously, you know this is the circle. It's not a function. I mean to say a circle is not a function. So in our definitions there, this line is supposed to cut the graph at one place only, but this one, it cut the graph at 2 points. So this is not a typical example of a function. The next example, it would be this guy here. Again, the question that we may ask ourselves, is this the graph of a function? It doesn't have to be something that you know, but if you're having a graph, you do have the test. You can test whether it's a graph of a function or not. So again, we're having a line there, our vertical line, and then we will see if it doesn't intersect the graph more than once. Now, if we move that line to the left, we can see there, if there's somewhere, there's a point where it cuts the graph at 3 places. So definitely this cannot be an example of a function. This graph doesn't belong to function. It's not a graph of a function. Lastly, but not least, if we're having a graph like that, which I believe some of you have seen it, some of you are seeing it for the first time. Again, we can use our vertical line test to test as to whether this is a graph of a function. Again, if we're moving that line from left to right, we can see there is no way that that line intersects this graph more than once. So this one basically is what we're looking for, is a graph of a function. Now we come to explore another question which is very interesting and also highly examinable in grade 12. The question of whether to decide whether a function is one-to-one or many-to-one. This is very important because it determines also if that information is very useful when you are determining the inverse of a function. Because now in inverses, what happens is, in order to know not all the inverse, you will just learn not all the inverses. If it's a function, there's no guarantee that the inverse of that function will itself be a function. So, but if you know whether a function is one-to-one or many-to-one, it would assist because all the functions that are one-to-one, their inverses are automatically functions, but the functions that are not one-to-one, say many-to-one, their inverses are not functions. So in the next test, we are doing a horizontal line test. So the horizontal line test is assisting us to tell whether a function is one-to-one or many-to-one. That is what we're going to embark on in the next test. So now we are looking at the horizontal line test. What is this test telling us, learners? Whether they'll remember whether the function is one-to-one or many-to-one. What the horizontal line test says, a function is one-to-one, is a one-to-one function if whenever we draw a horizontal line and move it up and down, intersects the graph of the function only once. So if that happens, you can say that that function is one-to-one function. If that line that you draw whenever you can draw a horizontal line and it intersects the graph only once, then you can say the graph is a one-to-one function. But if it cuts it more than once, then that graph is a many-to-one function. So for instance, here we're having these two examples there. We have in that graph there, which is obviously you can see it's a graph of a function by using a vertical line test. If we draw any line on this graph, we can see it will intersect this at only one point. Again, if you're having this, which is something that most of you are familiar with, yes, it's a parabola. If you draw a vertical line to this graph anyway, it will intersect the graph of this function only once. But now, since we are already confident that these two are functions, we are interested to know whether they are one-to-one or many-to-one. Then to do that, we use a horizontal line test. So here is our horizontal line. Let's see what the horizontal line will do. Then if we move that line upwards, we can see there for this graph, it intersected only once anywhere when you are moving it up or down. But for this one, you can see that this line has intersected this graph here and there. So this one we can say is a typical example of a one-to-one function, and this one is a many-to-one function. So that is it, learners. So remember all that we have got. We said we have got relations. When we moved on, we have a special relations, and then we define those relations as two functions. And then we said we can categorize functions into two. We have got a one-to-one function and a many-to-one function. And then we said, okay, we have got tests. We have got a vertical line test and a horizontal line test. A vertical line test is used to test whether the graph is indeed a graph of a function. And then the horizontal line test is used for function, but you just want to know whether a function is a one-to-one or many-to-one. With that having been said, learners, just keep on following this channel, and we will. I promise that we will upload more and more interesting stuff that will assist you to make you tough, to make you fully prepared for the examination. And please, if you find this information very useful for yourself, subscribe and also share with other learners. They need to know this information. Just keep on following my channel, because I will keep on uploading some very useful information that will assist you to prepare for the final examination. Good luck. I would like to thank you for watching this video and also logging into my channel. And please, if you find it very useful and important for you, just subscribe so that you may not miss up for all other videos, very important videos that will be uploaded in the channel. And also share this information, share the link, share the videos with your friends, because they have to get this information. Please feel free to put a comment and also follow me on my Facebook page, which is called Mathematics Champions. If you go into your Facebook and go there to check, you go there to search and search Mathematics Champions. You can follow me, because most of the things that we'll be doing here, I will upload also on my Facebook page. So share this information with your friends and make sure that you are prepared, you are fully prepared for the examination. Thank you, thanks a lot. And also, most importantly, don't forget to like.